Hi, everybody. This is Carl Freund again with Cambrian-AI Research. And today I have two machine learning scientists from Qualcomm Research. So this is the organization that's kind of ahead of the product curve. These guys are working on fundamental research, applying AI to wireless communications and RF sensing. Arash Babudi and Daniel Dickman. Hi, guys.
Hi.
Hi, Carl.
Thank you
Nice.
for having us.
No, thank you guys for joining. I've written a short piece published on Forbes, and we thought it'd be good just to get on the phone and provide a quick update to people of what you guys are working on and why it's important, especially why it's important. We've all had situations where our phones don't seem to have the signal quality we'd like. And when you're inside of a building, you don't have satellite communications for location sensing, so you can't really use your phone to navigate from one floor of a building to another floor of a building. Those are the kind of problems these guys are solving. So, Arash, why don't we start with you? Why don't you talk to me about machine learning and its applicability to solving some of the wireless communication challenges? What problems are you trying to solve?
Yeah, so I mean, I always like to start talking about wireless by just describing a typical wireless network. There are multiple smart devices trying to perceive the environment, make some decisions, estimate something, and communicate, let's say, by the base stations to prepare best platform for communicating things and providing services on top. And in that sense, you have smart agents trying to estimate, run inference tasks, perceive the environment, interact with the environment, and make decisions. And all those tasks, if you look at it, they are like a classical machine learning tasks in sentences. And whenever with data, we can provide better understanding of the complicated propagation environment that exists for wireless. With machine learning can improve the methods that we have currently for running all these tasks. We can rely on gains of machine learning and be hopeful that it improves our stuff.
So give me an example. Give me an example that I might encounter today, that when your technology, your research turns into technology that's in handsets powered by Qualcomm devices, that those problems would go away. Give me a couple of examples.
Yeah, I mean, let's just start. I think the core of one of the core problems in wireless communication is understanding the propagation environment itself. Because at the end of the day, if we are transmitting some waves over the air, it goes through a very complicated environment, a lot of reflections, a lot of objects in the middle, and gets received by your device. And if you understand how this changes, then understand that details of that propagation, you can always design better algorithms. So channel modeling plays a very, very important role in wireless communication, and has always played an important role in wireless communication. This is part of, let's say, it's about learning laws of physics and interaction of laws of physics with the environment better. And again, this area, you can use classical methods for that, but you have to hard code some of the assumptions. You have to have a very rigid assumptions. You don't have flexibility of machine learning. And with data, you can overcome that. You can have flexible models. You can have accurate models and fast models as well. And all that help you design a much better algorithm for complex environments that you have. So I would say, like, channel modeling is probably one of the more prominent examples that I can give for these tasks.
Interesting, very interesting. So Daniel, let's talk about RF sensing and what problems are you trying to solve with machine learning?
So RF sensing is when you use the signals that are being transmitted, for instance, from a phone to an access point, when you use those to actually perceive the environment. And what we're particularly focused on is positioning. So we do two types of positioning right now. One is active, where you're trying to locate a device. So you're walking with your cell phone through a building and you want to know where are you in the building, and GPS doesn't work. So maybe you can use Wi-Fi or 5G signals to determine your location. So that one, yeah, is relatively straightforward. The one that's harder or more challenging, I think, is the passive positioning, where you're trying to use access points or cell phones or a combination thereof, and then trying to perceive the person that's walking through the signal. So as a person walks through an RF signal that's traveling from a sender to receiver, it slightly disturbs it, and we're trying to use it as kind of radar to localize people.
So you're actually using the RF signal like a radar, is that right?
Yeah, that's correct. Yeah, it's like, passive bistatic radar. It's called.
Yeah. Interesting. So, so I know you guys are in research. You can't talk about product schedules and things like that. But, what kind of projects do you envision as your next set of challenges you want to tackle? We'll start with you, Arash.
Yeah, I want to continue on my previous answer, basically on channel modeling. I would say designing better channel models and building better channel models enable developing much better algorithm, much more efficient algorithms for our devices, better deployments, all that. So it has impact in every single area. So of course, designing better models, building better models, having better understanding of what happens in a propagation environment, that's definitely one thing. And of course, on top of that, once you know how to model, you want to be able to estimate that. You want to be able to understand what is the channel that I'm communicating over, and building algorithms that can understand the channel based on the model that we built. That's also part of it. And I think these two will play a huge role for the, I think, the next generation of AI-enabled products.
Interesting. I noticed in reading some of your work, you talk about how the channel can be reflected off floors and ceilings and walls, or even blocked by an object between the access point and the device. Can you talk a little bit about that and how machine learning addresses that kind of physical environment that changes so rapidly?
Yeah. So when you transmit, let's say, a signal, it's just assume that you're in a mountain and you're shouting. You receive multiple reflections of your voice, and we humans, we magically can disentangle probably some of the echoes, but our devices, they have challenges disentangling all that, because all these reflections and direct signals, reflection, scattered signals, they interfere with each other, and you receive their interference actually at your device. So in wireless, one of the biggest achievements of wireless was to actually utilize this multipath to build better communication, to build more robust communication schemes. But with machine learning, we can do even better. We can try to build better better beams, communication beams for transmitting data. Meaning, we can utilize the reflections for transmitting more effectively compared to what we did before, which was nice, mathematically very elegant, but now we can go even beyond that with machine learning. So disentangling those propagation effects and try to build on top of that.
So you're actually using those reflections and other echoes or what have you to glean more information and be able to improve the signal quality?
For improving communication performance, and I think even this becomes probably more important in perception tasks. So I'm sure Daniel can comment a little bit more on that. That's, I think, utilizing these complicated propagation environment, this multipath for sensing. That's a huge opportunity. So
interesting. I love it when AI just disappears, when machine learning is just helping something work better and you don't have to push the button that says use machine learning. It's just embedded. And I think that's the future of machine learning as it becomes more and more pervasive. Daniel, how about you? in terms of RF sensing, can you speak a little bit more about what the long-term trajectory is to the problems you want to solve?
Yeah, so a big one right now is the 5G positioning. We had several demos this year at Mobile World Congress. So to make it really, so to position a 5G device really precisely indoor. And that's exactly as Arash said about like the multipath reflections. So if you have a really naive modeling of your problem, they're actually detrimental, right? So the simple one would just be, oh, the access point sends a ping and the phone receives it and we time how long that takes and you know its position. But with these multipath effects, like these reflections, you can actually use them to your advantage, that you see like multiple anchors, or like it helps fingerprint basically each location in the indoor environment, give it like a unique signature. And if you're able to use machine learning to tie all that information together and to solve your precision, yeah, then we hope that we can get to really great precision, well, both for people, right?
And that's is that in 3 space? Is that in 3D?
Yeah, it's 3D positioning with really high resolution. So for people, the advantage would be you're at an airport, you want to know your way, you can just see yourself on the map. But it can also be used for robots in factories, or even you could put like a little 5G tag on individual boxes in a warehouse and you'd never lose them again, because they would basically report themselves where they are. So these kinds of things. And beyond that, we're interested in learning more, like sensing things about humans. So for instance, respiration rate is very interesting, or you're monitoring your sleep pattern. What I find exciting personally is like for XR applications that you could sense the pose of a human. So you're playing a game, right? But you don't want to be filmed by cameras. You could do that all maybe with RF sensing. So measure the pose of a human being. But it's kind of longer term, right? And my personal interest.
Oh, that's a game changer. That's a game changer. But even 3D sensing, I can imagine, retail organizations in large shopping malls or buildings in downtown New York, where people could pull out their phone and say, I want to find this brand of shirt. Where do I go? And it could actually guide you to where it is to make the purchase.
Oh yeah, those kinds of applications. Yeah.
Wow. It's a brave new world as we see machine learning and artificial intelligence penetrate new problem areas and solve things that today we have traditional classical techniques for approximating it, but the accuracy is inadequate or even possible in some environments. It's fascinating. Well, thank you guys so much for helping me and my audience understand what it is you guys are doing in research. We look forward to hearing more about this, and we especially look forward to seeing it in mobile devices powered by Qualcomm. So thank you guys very much.